Hi everyone, in this video I would like to talk about integration by parts. And this is a great technique when you have a product. So I'm going to write this down, integration by parts. This is a great technique to use when you have a product or a multiplication in your integrand. And when you don't have like a function composition. So in the last example I did, we were talking about U substitution, and that was a great technique to use when you have a function composed with another function, like a layering of function or like a chain rule idea. But in this example here, there's not really an inner and outer function. There's not really a good choice for a U. You could certainly try a U substitution. No one's going to stop you, but it might not work out well. And so then you just back up and try a different tool. But because this is a product, right away I'm thinking this is a good candidate for integration by parts. And when you do integration by parts, our formula is going to be UV minus the integral of V du. And our original integral is u dv. But this right-hand side is really what you need to remember. Now, to set this up, I need to make some decisions. I need to choose what's going to be u, and I need to choose something that's going to be dv. And I'm going to choose u to be something that gets easier, or maybe simpler, less complicated. I'll just write easier for now. It's easier to deal with when differentiated. And the dv, that is something I want to choose. I mean, I've got a choice here. I've got x, I got ln of x. Who's going to be u? Who's going to be dv? I've got to make these decisions. And dv, I want to choose dv to be something that gets easier when I integrate it. And it might not get easier, but it certainly doesn't get any more complicated. So, when I'm looking at this integral x times ln of x, let's see, if I tried to integrate ln of x, I mean, that's not quite clear. If I try to integrate just the x, that's going to be not bad at all. That's pretty doable. So I'm thinking, let's choose u to be ln of x. And then that means that du equals, derivative here, 1 over x dx. That was totally pain-free because I know the derivative of the natural log. So that was really good. And then dv over here. So if this is u, then dv is going to be everything else. So dv is going to be x dx. And now I need to integrate both sides. So the integral of 1 dv, that's just going to be v, that's good. And the integral here is 1/2 x squared plus c. I'll keep track of my constant at the end. Okay, so now for my formula, integration by parts, I'm going to need uv minus the integral of v du. So what I'm saying is that the integral of x times ln of x dx equals uv. Well, uv is going to be ln of x times v, which was 1/2 x squared. minus the integral of v du. Okay, let's clean this up a bit. So I've got 1/2 x squared times ln of x minus, I'm going to bring the 1/2 out in front. I've got an x squared and an x, so we've got 1x that's going to cancel there. 1 factor of x is going to cancel. And now I'm just down to a lovely little integral that I need to compute. The integral of x is just going to be 1/2 x squared. I'll put my plus c on the end of this. And final answer would be 1/2 x squared ln of x minus 1/4 x squared plus c.